AI is evolving at an unprecedented pace, shaping the future of technology and redefining how we build applications. But before we dive into Chapter 2, let's quickly recap what we covered in Chapter 1. Last time, we talked about why AI engineering is booming, how pre-trained foundation models are replacing traditional ML pipelines, and why self-supervised learning changed the game. We also explored autoregressive models like GPT-4 and masked language models like BERT, understanding how they work and why they matter. Most importantly, we discussed AI's impact on jobs and how we as professionals can adapt to this AI-driven shift instead of fearing it. Now, moving forward into Chapter 2, we'll go even deeper into foundation models, the true backbone of modern AI applications. We'll break down how they work, why data is critical, how model architectures are evolving, and what it takes to fine-tune them for real-world applications. This video is based on my personal interpretation of concepts from AI engineering. Building Applications with Foundation Models by Chip Huyen. It is not an official summary of the book. All views expressed are my own. A foundation model is only as good as the data it was trained on. The capabilities and limitations of these models are heavily influenced by data curation, ensuring datasets are high quality, diverse, and relevant to specific applications, and distribution of data. Training on well-balanced datasets allows models to generalize better and perform across multiple domains. For example, domain-specific models like medical AI assistants require training on high-quality industry-specific datasets to produce reliable outputs. The transformer architecture dominates foundation models for language tasks, thanks to its attention mechanism, which helps models process long-range dependencies. Attention mechanisms allow the model to focus on relevant parts of input and understand relationships between words in long sentences. While transformers are dominant, newer architectures like Mamba and Jamba are emerging, offering different trade-offs in efficiency and performance. Larger models tend to perform better, but scaling comes with computational costs. Understanding scaling laws helps balance the number of parameters. More parameters lead to better generalization, but increase compute costs. Training tokens. The amount of training data affects how well the model learns, and compute budget. Finding the optimal balance between model size, data, and training cost is crucial. The Chinchilla paper suggests that optimal training requires about 20 times the number of model parameters in training tokens, helping engineers make smart scaling choices. Pre-trained foundation models need post-training techniques to align with real-world applications. Supervised fine-tuning using labeled data to refine model performance for specific tasks, and preference fine-tuning, training models with human feedback to generate more user-friendly responses. For example, RLF helps chatbots like ChatGPT reduce biases and improve engagement by ensuring responses align with human preferences. Foundation models don't always generate deterministic outputs. They use sampling to create diverse responses. Temperature scaling controls randomness in output. Lower values make responses more predictable. 𝗏K and 𝗏P sampling filters unlikely outputs to improve response quality. Structured outputs use techniques like prompting, post-processing, and constrained sampling to guide model responses. For applications like legal AI tools, structured outputs ensure accurate, legally compliant responses. One major challenge in AI is hallucination, where models generate false or misleading information. This happens due to overgeneralization, AI making predictions based on incomplete or biased data, and lack of grounding, models trained without strict validation mechanisms. Mitigating hallucination requires better data filtering, retrieval augmented generation, and fine-tuning strategies. Building enterprise AI solutions requires more than just fine-tuning a foundation model. Key techniques include customization through prompt engineering. Carefully crafted prompts improve model responses. Retrieval augmented generation enhances models by fetching external knowledge, and fine-tuning for specific use cases improves model accuracy for industry applications. For example, finance AI tools must be fine-tuned to handle regulatory compliance and risk management tasks. Integrating foundation models into real-world applications requires data strategies, data acquisition, annotation and quality checks, user feedback systems, continuously improving models based on real-world user interactions, and continuous evaluation, detecting biases, failures, and performance degradation. Building AI-driven applications isn't just about model selection. It's about making strategic decisions in resource allocation, balancing compute, data, and human effort, risk management, identifying failure modes and ethical risks, and innovation and competitive edge, leveraging AI to drive business value. Foundation models are versatile and adaptable across industries. Training data quality is key to model success. Transformers remain dominant, but alternative architectures are emerging. Post-training techniques refine models for real-world applications. Sampling impacts AI behavior. Understanding it helps guide model outputs. Hallucination risks can be mitigated through careful engineering. Custom AI solutions require fine-tuning, retrieval augmented generation, and structured outputs. Evaluation and feedback loops ensure AI remains effective over time. Foundation models are shaping the future of AI, but their success depends on how we train, fine-tune, and deploy them. By understanding key concepts like self-supervision, attention mechanisms, and structured output generation, we can build AI solutions that are scalable, responsible, and impactful. Stay tuned for Chapter 3 insights in the next session. Let's navigate this AI transformation together. Thank you for watching. If you found this video useful, don't forget to like, subscribe, and share.